Hello, awesome math students. Today we're starting our new unit, Unit 3, which you can see is on proportional reasoning, which is another fancy term for using proportions. And it ties into a lot of our real world, real life math. So it's going to be a nice change from what we've been doing. We're going to do lots of consumer activities, shopping kind of things, and imitating going out to dinner and things like that. So our first lesson is going to be on rates and unit rates. So if you look at the picture that I've put here, this is SpaghettiOs, which I know you guys all ate when you were younger. So we've got two different sized cans. We got a smaller can for 98 cents, and we've got a large can, a family size can, for $2.12. So part of what we're looking at today is being able to look at this and say, well, which one's the better deal? Well, you assume that this bigger can is a better deal, but there's something called a unit rate, which simplifies our math. And if you look here, they've already done it for you, and most stores have these on their labels. So in this sense, you're getting your unit rate is 6.6 cents per ounce or whatever the measurement is. And in the big can, it's 8.1 cents per ounce. And so if you look at it that way, then the smaller can, even though it is a small can and you'd have to buy more than one can, it'd be better to buy that smaller can because it costs less per ounce. So that's the kind of thing we're going to be looking at moving forward. Our learning targets, I put a whole bunch of them here. We're doing the preliminary stuff today. We're working on vocabulary, but then we're going to be working on how to write proportions that represent equivalent relationships, how to solve proportions to find a missing term, how to apply proportions to convert between units of measurement, and then how to apply proportions to solve practical problems like scale drawings. So if you've ever seen an architect, they draw blueprints to build big, huge things because they can't draw things that big. And then how to solve problems involving tips, tax, discounts, because I know you guys all like to shop and you all probably love discounts, going and getting sale price on items. So if you look at this example, I put this out here. Joey Chestnut, he was the 7th time that he's won this competition. It's the Nathan's hot dog, seeing who can eat the most hot dogs in a certain amount of time. So if you look at their scores, we have this person here ate 49 hot dogs in 10 minutes. Mr. Joey Chestnut ate 69 hot dogs in 10 minutes, and this lady over here ate 50 hot dogs in 10 minutes. So those are their rates. And we're going to go over what that vocabulary is, and we'll come back and talk about him in just a minute. Aside from being thoroughly sick, he is a champion. So let's look at our notes. Pull out your notes. This is page 3. We're going to talk, I'm sorry, not page 3, page 2, the top of page 2. If you think about ratios and what is a ratio is basically a comparison of two different things. So I could be comparing, for example, with Nathan, or not Nathan, in the Nathan's hot dog thing, we compared how many hot dogs they ate and how many minutes. So we're comparing those things and putting them together. There are actually 3 different ways that you can write ratios, and there's different comparisons that we can do. So if you think about different comparisons, you can either compare the part to the whole to the whole, or the part to the part. I'll give you a second to write that all down. And I want to explain what that means. So if you look at this picture that I've put here, this is a middle school class. And when we say part and whole, part would be which part of the class, and then whole would mean the whole class. So if we're comparing part to the whole, we have to pick which part we want to compare. So what if I wanted to compare boys to how many boys are in the class? If you look, we got a boy here, we got a boy here, we got 2 boys here and here, we got a boy here. I think this is a boy sitting back here, can't tell. We've got a boy here, a boy here, a boy here, and a boy here. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So for the sake of this example, maybe 10. Did I count that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 10. There are 10 boys in this class, and we have a total or a whole class of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 kids. So in this sense, we're comparing boys to the whole class. How many boys? And then the whole class. Now, could I also compare part to part? I could. I could say, okay, how many boys and how many girls? Well, we already said there was 17 boys. Now let's count how many girls, and I'll make the girls red arrows. 1, 2, 3, 4, 5, 6, should be 7. 1, 2, no. Okay, so should be 7, no. Yeah, 7 girls. No, yeah. Sorry, that's not 17 boys. I was confusing myself. Okay, so if we know that there's a total of 17, and I subtract the number of boys, which is 10, that tells me the number of girls, which is 7. So if I compare part to part, boys to girls, it's 10 to 7. I could also compare whole classes. I could say how much is in Mrs. Inquist's class versus Mrs. Guzman's class, or how many is in Mrs. Gladwell's class versus Miss Westmoreland's class, and compare them that way. That's whole to whole. Okay, so let's look at some other ways that we can write. We said there was 3 ways that you can write them. Here's your first way, here's your second way, and here's your third way. And we're going to go through each of these right now. Okay, your first way is you can write them as a fraction. And this is the most common way, is to write them as a fraction. The whole is typically on the bottom, and the part is typically at the top. So sometimes whole. As long as you're keeping everything lined up the same, it should be fine. And it also is important for you to note that I want to highlight that your fractions should be simplified. So that means that when I I don't want, for example, I don't want 4/6. I would actually simplify that and say 2 out of 3 or 2/3. Okay, so let's look at this example here. What is the ratio of shaded stars to all the stars? This is a part to whole, because I'm looking at the total and I'm looking at part of the stars. The number of shaded stars, I have 1, 2, 3, 4, 5. So I have 5 shaded stars, and I have a total of 10 stars altogether. So my fraction would be 5 out of 10. But I want to simplify it, so I'm going to divide each side by 5. So my simplified fraction is 1/2. And that's pretty standard, easy fraction stuff. Okay, your next one is you can write a ratio using English. What's this little symbol right here called? That's called a colon. So in this case, you can write the simplified fraction. The numerator goes on the left, the denominator goes on the right. So I simply take this numerator, write it first, and then I take the denominator and write it second. So let's look at this example over here. What's the ratio of triangles to hearts? This is a part to a part comparison. So I have 1, 2, 3, 4 triangles, and I have 3 hearts. So my fraction would be 4/3. It's important to note that you always do it in the order that it's given to you. So I have triangles on top and hearts next. And if I were to take it and write it using a colon, I would just simply write it 4:3. This usually you see with sports. If you've ever heard in football or with horse racing, especially right now because they're gearing up for the playoffs with football, you'll say that the Packers, which is my husband's football team, the Packers have a 4-to-1 chance of winning the Super Bowl. That is usually for betting purposes, but we don't bet. But that is whether or not they have a good chance or a poor chance of winning the Super Bowl. So that's where we use this representation typically is with sports. You can also write a ratio with words. And we typically use the word to when we're comparing two things. We say boys to girls, 3 to 5. So you use that word to. And the first item goes before the second item. Oops, I should say second. After the word to. And for all, it's important to note this, for all ratios, the order that it's given to you is important. So don't get that confused. So let's look at this example. We have 18 footballs and 10 basketballs in the ball bin in PE. And they want to know what is the ratio of basketballs to all the balls. So this is a part to whole comparison. So I'm looking at the number of basketballs, which I know is 10. Total balls, I would take the number of basketballs and the number of footballs and add them together, which is 28. So I have 28 total balls in the ball bin. So if I write that as a fraction, I get 10 over 28. And I'm going to simplify that. I'm going to divide both of those by 2. And that would give me 5/14. And to write it as words, I would say 5 to 14. You could also say 5 out of 14 balls are basketballs. You typically see this representation in advertising when they say 2 out of 3 dentists recommend this chewing gum, or 4 out of 5 dentists recommend this toothpaste, that kind of thing. So the different ways of writing the same thing, typically our ratios for all our intents and purposes will be fractions. Okay, so let's go back to Mr. Chestnut. We said that he ate 69 hot dogs in 10 minutes, and we're going to write those in the 3 ways. The 3 ways, remember, are as a fraction, using a colon, and in words. We've already done it in words. This is hot dogs in 10 minutes, so that is basically in words, so we don't have to do that. But as a fraction, it would be 69 hot dogs in 10 minutes. And I cannot simplify that because 69 is odd and 10 is even. And then to use a colon, I would simply write 69 to 10. It's that simple. That's the very basics of ratios. Now, if you turn your notes over, we're on page 3, and this is just vocabulary that I want to go over to make sure you have it. Again, a ratio is simply a comparison of two numbers, and it's as a fraction, so it's by division, and it's written as a fraction. It compares typically, most of the time, part to the whole. Whatever the whole is. It could be part of the money I get for my birthday out of all the money I got for my whole birthday. And don't forget to simplify. A rate is also a comparison of two measurements, but they have different units. So at the beginning we talked about the same shapes. Those are basically the same thing. But when we talk about a rate, we're talking about more what we just looked at with the hot dogs. How many hot dogs he ate in how many minutes. Two different units that we're looking at. And the key word here that you're going to look for is per. So I said, how many miles are you going per hour? How many sodas per dollar? Or how many dollars per soda? How many math problems can you do per hour or per minute? When you guys used to do those really fast time drills with multiplication, you were saying how many problems could you do per seconds or per minute. The unit rate is basically the same thing as a rate, but it has been simplified so that it has a denominator of 1. So that's where we say, how much are you paying per soda? This is really important when you're shopping, especially for groceries and things like that, because it helps us find the best deal. Because we're always looking at stores having sales, and we'll say, oh, come and buy. You can get 3 DVDs for $10, or you can get 12 packs of soda for $10, and sometimes other stores will have it where you get a 6-pack for $1.50, and you got to be able to look at things and say, well, what's the better deal? And what we're going to learn is how to do that, and that'll save you money in the long run and help you be good consumers later on. What we're going to do is take all of what we just talked about today and use it to make proportions. And a proportion is simply a statement that two ratios
Brennan, Louis, please come to the main office.
That two ratios are equal. Proportions are used to calculate it for a missing value. So I'll explain. And we use cross products or cross multiplication. Oops, sorry. To solve proportions. So if we look at it, we've got part to whole comparing to part to whole, or part to whole with percent over 100, because a percent is part of 100. And when I say cross products, what I'm looking at, and you'll need to write this down, if I have a ratio A over B is equal to C over D, I can multiply A times D and then multiply B times C, and it's going to be equal. So that's basically all that we're going to be doing with proportions, but proportions help us with consumer math and so on. And then the last thing you need to know is a percent proportion, which is a special kind of proportion that is used when we have percents. And so that's when we say, we use this a lot specifically for your grades. So if you say I got a 5 out of 10 on a quiz, what percent is that out of 100? And that's where we can use a proportion to figure that out. Okay, so let's look at some examples and then we'll be done. These are just some ratios that I want you to write as fractions. So if we look at the first example, we have 18 out of 45 cans. So we're going to write that as a fraction, 18 out of 45. And then we have to write it in simplest form, which means we have to simplify. Choose the number that you know will go into both of these. You can use 3. You can use 6. You can also use 9. And I'm going to use 9 because it's the largest. 18 divided by 9 is 2. 45 divided by 9 is 5. So my final answer, my final ratio, if I have 18 out of 45 cans of soda, that basically comes down to 2 out of 5. Again, we're just taking the order that it's given to us. The top number goes as the numerator, the second number goes as our denominator, and we simplify. I can divide both of these by 15, and my simplified ratio will be 1 out of 5. The next one, notice I've got the bigger number comes first. That's okay with ratios, because sometimes you will have a bigger number. We have 155 apples to 75 oranges. And I'm going to divide each of these by 5. And if I divide each of those by 5, I get 31 over 15. And I'm going to leave it like that. We do not have, I'm going to put a little note, no mixed numbers with proportions. Because if I have a mixed number, I wouldn't know what that whole number goes with. Does it go with the apples or does it go with the oranges? I don't know. So we leave it this way so I can easily say, well, there's 31 to 15. For every 31 oranges, every 31 apples, I have 15 oranges. That's basically what we're saying. If I say 32 out of my 64 calculators are broken, which we hope never, ever, ever happens, we write that as a fraction, 32 over 64. And I'm going to divide those by 8. I would end up with 4 over 8. I can simplify that more by dividing by 4, and I get 1/2. That would mean that half of my calculators are broken. Not good. Okay. Let's look at a unit rate. And I want you to put a little note in your notes. I want you to add to find the unit rate. Divide both numbers by the denominator. That's all you're doing. So if I look at this, first I have to set up my ratio. I have $25 for 3 DVDs. And again, I'm looking, is this a good deal? So I want to find out how much is it per DVD. So I'm going to divide both of these by 3, because that's my denominator. 25 divided by 3 gives me a decimal, which is 8.3333333333333. I'm going to look at it in money, so I'm going to just look at these. So basically, it's like having $8.33 per DVD, or for one DVD. If I read 10 pages in 2.5 hours, I write it as a fraction. I'm going to divide by my denominator, which is 2.5. And that tells me that I can read 4 pages per hour. It's not the greatest, but if you need to take your time to read, that's okay. So what if we look here? Let's see, we've got 2 examples. One is miles per hour and one is miles per minute. We're going to see if we write these, and you can maybe think of an example of how 250 miles per 5 hours. We divide by 5 because that's our denominator. And that gives me 50 miles per hour. So if you think about that, that's like the speed a car would go. But if we think about this one, we're going 4.5 miles in 25 minutes. We're going to divide by 25. And yes, you will get a very tiny decimal. So that means we're going 0.18 or 1800ths of a mile per minute. And if you think about this, this is similar to what you would maybe do if you were walking, or if a grandma was walking, maybe not you guys, but a grandma. So those are examples, and see how you can break down the $25 for 3 DVDs. That's less than $10 a DVD, but what if I got 3 DVDs for $15? It would be a little bit better deal. Or, you know, maybe $15 for 5 DVDs would be an even better deal. So it helps us break things down to see how fast we're going or how much we're paying and that kind of thing. The other kind of problem you're going to have to look at is determining the best deal. So here I gave you a situation. We have Best Buy has 3 video games for $39.95. GameStop has 5 video games, and you can ignore this F. I don't know how that got in there in the notes. 5 video games for $57.95. First step, we want to put our ratio, and I said usually order counts, but with these we always want to put money on top. So $39.95 goes on the top because I want to know how much it costs per video game, and that's for 3 video games. I'm going to divide by 3. If I divide by 3, that comes out to 1, 3, 3, 1, and then 6 repeats. And again, I'm going to be looking just at money. So I'm going to look here, but this tells me whether that 1 goes up to a 2. And for this, it does because 6 is higher than 5. So my money, you want to think of $13.32. And then for the second one, we have $57.95. Remember, money goes on top for 5 video games. So we divide by 5. And when I do that, I get $11.59 per game. So if you look at this, which one is the better deal? Would $11.59 per game be better than $13.32 per game? Or is $13 per game better than $11.59? If you think about it, this is a much better deal because I'm saving just about $2 per game, which I like to save money, so that would be a good thing. Okay, that's all we have for this lesson. Go ahead and log in and do your quiz. It is going to have some find the better deal and take some of the vocabulary from your notes. So make sure you have your notes handy.